Okay, so this is the second part to lesson 2, and what we're going to be doing here is we're going to be using linear regression to solve a problem. So we need to use our technology for that. So here, page 32, example number 2, we're talking about a bicycle racing event that occurs once a year on the same day. The winner is determined by the person who travels the furthest in 1 hour. The table below shows the winning distances and the year in which they're accomplished. So you're on page 32, and we see a little table that talks about the year and the distance. You can see it there. So it's got year versus distance. Woo! Okay. Now we have to decide what our independent variable and our dependent variable is. Remember, I said that if you're dealing with time, then time will be your independent variable. So you've got years there, so that's going to be your independent variable, so it'll go on the horizontal. Your y value will be your distance, or your dependent variable will be your distance. So we're going to enter that data into our calculator, and we're going to use linear regression to solve this problem. So here we have our calculator. So we're going to follow these steps. Now these steps for calculator for doing a linear regression are on page 56 and 57 in your notes package. So the first thing it wants us to do is turn your diagnostic on. So second function, 0 x minus 1. That's what it said to do. And then it said scroll to diagnostic on. So it's way at the bottom. Press enter. And then press enter again. So it's done. Okay. Then we want to clear all equations from y. So I looked at my y. I've got no equations there. I'll press clear just in case. Okay. Then we're going to clear all lists. So I go stat. And it's important, you don't want any extra data left in from something else you might have done. So we're just clearing the calculator to allow us to do that, okay? So you go up to the top where it's in the top menu, you hit clear and enter, and it will clear that column. Same thing here. I'm in L1, clear and enter. Now what we're going to do is we're going to enter our data. So 2003, 2004, there was nothing for 2005 and 6, but there is for 2007, 2008, 2009. Okay, then we go over to L2. We're now going to enter our dependent variable, our y values. 83.72, enter. 84.22, enter. 86.77, enter. 87.12, enter, and 90.60, enter. Now just double check those numbers and make sure they match up with what's on the page. I think we're good. Don't see any errors. That's awesome. Okay. Alrighty. Now it says determine an appropriate window. Well, we can adjust the windows using our calculator. We've entered the data from the chart, and then what we're going to do is we're going to turn on our stat plot. Now stat plot is up here, so it's the second function. So second function, y equals, and under 1 I can see that my stat plot is there and we want it on. So we're good. Now if you look down here, you can see that you can double check and make sure that your X list is in L1 and your Y list is in L2, and they are. So we're good there. Now we're going to adjust our windows, and to do that we hit zoom and we go all the way down to 9. Zoom stat. Enter. Now my data has been plotted. Now I just want to check my windows. See, so it did all that work for me. It adjusted my windows based on the data. So I'm going to look at my graph again. Isn't it a thing of beauty? Okay. And now I've got my scatter plot. I've graphed it. Sorry, you have to look at my scraggy nails in this. Now we're going to find the regression equation. So I hit stat, again, stat, and then I go over to calc up top. Now looking at our list, I want a linear regression. So I'm going to go down to 4. When I hit 4, then it has linear regression up there. Now, if the data is in list 1 and 2, then we're going to do the following. We hit second function 1 for L1, then you put the comma in, and then second function 2. And then that gives us our L2, and then hit enter. Now what we see there is we see our linear regression. We've got our A value, which is our slope. We have our B value, which is going to be, it's a negative 1914, so that's the year that it's negative. That's interesting. We have our R values, and our R values tell us how close the points are to correlating with the data, because it's a scatter point, so it's not currently existing in a nice pretty straight line. But so it tells us that our scatter point's got a little give to it, right? The closer those R values are to 1, then the closer our points are going to be to our line of best fit. Okay, so we want to draw our line of best fit, so this is what we do next. We hit vars, so that's this button, okay, and we hit statistics, which is 5, right? So that's 5 there. Once we're there, we're going over 2 steps to equations, and the equations that we're picking is number 1, because it's the regression equation. So we hit 1, and there we have our regression equation all mapped out for us. Now when we hit graph, please work. It's supposed to draw a line of best fit for me, but it didn't, and this is the problem I've been having. The other option you can have, like if we go back here, what we basically have from our calculator is y is equal to 0.99716417910448x plus negative 1914.02477611194. So that's the equation we have. That's what it says on our calculator there. So I'm going to go into my y equals, and I'm going to type that in, because that's the equation I want. There's a way to make your calculator doing it, and I've gotten it to do it, but I'm not super good at it yet. So I would encourage you to watch some of the other videos, and maybe those of you who are technologically superior to me, because I know you're out there, will be able to get it to work. So if I graph that, so now I put it in my y equals, and now I have my nice, beautiful straight line, which is my line of best fit. So you get the equation. If you look at the screen, it's given to you right there, right? That's your linear regression. And that we did go through the steps to do that. Okay, so that is the equation that they're looking for under C, and that's how you get there. Now, now it says interpolate what a world record distance might have been in the year 2006. So this is on the top of page 33. If we look at our graph, so in 2006, remember our x value is our 2006. Oops. Okay. So if I do trace and I put 2, doesn't let me do it. 2006. 2006, y is equal to 86.29. So that would be our value for interpolating. And how does that estimate compare? The next question says with the actual world record distance, 85.9 kilometers in 2006. So it's a little over, but it's in the ballpark. And then it says use your equation to extrapolate the year in which a distance of 82 kilometers was achieved. So if we trace down, because we want to get lower, so I'm just basically tracing my line till my y value hits 82. And it may not get there because of our windows, right? Oh, I'm almost there. So I'm just using, oh, yeah. It's a 2002-4. I might have to change my window to get there, right? So if I change my window and I go to maybe just 2000 and graph and then hit my trace. Okay, so because I want to get down to 82, right? Oops, I got to be on the line. It's, trace buttons. It won't get there. Okay, that's going. Okay, here we go. Can I get there? Can I get there? 82. I might need to even go lower, hey? Oh, wait, I went past. So it's really just using your buttons to get there. Probably 2001. But use that trace. We're outside the data point, so we're just estimating. Sometimes it's easier if it's graphed on paper. Sometimes it's easier if we can see all of the data points. We do have the technology to kind of do that kind of work. There's some need to knows at the end of the lesson. We talked about scatter plots being a set of points on a grid to visualize data. We've got our independent and dependent variables and our lines of best fit. And this is using linear regression. Hopefully it made sense. Like I said, the instructions are on page 56 and 57. And it's really that formula that you need. Graphing it on your graphing calculator, no one's going to know if you actually graph the line of best fit, but they will know if you have that information. And often they just do it to the fourth decimal place, not all those millions of decimal places that we had. We want to make sure that we know what interpolation is. It's estimating data between points, and extrapolation is outside of the points. Okay. Happy cycling. We'll trace on up there. We'll see what happens. Woo! Okay. I hope you followed along with that as we did it, because it's something that I don't do very often. I only do really when I'm teaching this course. So the more you do it, the better you'll get at it.